Okay guys, next question we're going to take a quick look at here on the channel is the 2009 intersecting planes. So tricky enough last part of this question, so we'll just set it up here. Let's look for the planned elevation, line of intersection, dihedral angle, and the hole that's cut out in 10 from the edges. That was a bit trickier than it might have looked. So I've just set these up in two different colors here to help you to follow it. Now I guess this is probably one of the tougher ways to get these questions here, where you don't know any points. You've got two triangles intersecting and you don't have any point on the line of intersection. Now the easy way to do this would have been to take a cut section through the AC line at this height. But look, just in case people aren't familiar with what I'm doing here, I'm going to take a horizontal section at two different heights completely. So this here is height 1 and that's height 2. So what you're doing there is you're chopping through the entire two planes there at two random heights, and that is going to give us 4 points. So I'm going to deal with height 1 first of all. So we've got a point on, I'll just label this now as well, that's ABC. Okay, so we've got our first point here is on AB in plan. So I'm just going to mark that there, and that's going to AC in plan. Okay. So that line here is a horizontal line that's like 72 above the ground, and that then also at this height there's a point on DE and a point on DF. Okay, so this line here is also 72 above the ground, and where these lines cross, both of them are at the same height. So I can bring this point up here now as well. That is 1 point on the line of intersection. Now down at the lower height there, we're going to do the same thing. So the second section that I took then is, it just happens to be 50 above the ground. So we've got a point on AB, corresponding point here on BC in plan. So this is a horizontal line, 50 above the ground, 50 above the horizontal plane. And I'm doing the same thing there then. I've also got a point on DE and a point on FE. Oops, need to be careful here now. FE is this line. So this is also a line 50 above the ground, and where both of those cross there, you may not be able to see that there now. That's probably after coming out a little bit light. Could just heavy it in, I suppose. So this is my line at height 2 there, and where they crossed. So that point there is a point on the line of intersection. I'm going to bring that up to there. So I can now draw the line of intersection, which I will put in red, and it just goes through these points. And obviously triangles can't be intersecting outside, so it's got to stay within the two triangles. So it's got to stay within the two triangles. So there is, in red, is our line of intersection, and that was one of the more difficult parts of that. So part 2 there was, so we set them up, and B was find line of intersection. So the next thing there is get the dihedral angle. So that involves getting a true length of the line of intersection. So here is my line of intersection in red. So I want to set up an XY line. This is my first auxiliary, XY1. So we're looking at 90 degrees perpendicular to the line of intersection. So I'm hoping this stays on the sheet. So the most important thing right now is to bring the two ends of the line of intersection, the two ends of the red line, but I'm going to project all the other points as well while I've got my angle set up. Okay, so the rule is projecting from here, the last XY line back. That's where our distances come from. And of course I forgot one important point here. I just forgot to bring, or did I? Maybe I didn't, sorry, no, maybe I didn't. So E is on the ground, so that's going to be E in the new view, and I can use the heights from over here. So I'll just zoom back there a little bit. Okay, so I could use the heights because I know all these heights as well. So A and C are both up 80. So A is up 80, or I gotta use the compass as well. Either or. So that's A. C is also up 80. Now D is the highest, which is up 105. Okay. And I'm going to just take there now some heights. I'm going to take the heights for the ends of the line of intersection, because as I said, that's the most important thing. So this end of the line of intersection is whatever the hell that is. So this is the right hand end. So I'm just going to keep that with a red dot. And the left hand end, well, that's here. So this is my line of intersection. So really I only need the line of intersection and one point off each plane, but anyway I'll just bring them all. So I've got A and D and C and E. I don't have B and F yet. So B was up 35. And F was up 55. It's a bit awkward there now that it's gone down onto the title box. Okay, so again I could join all these up, and I suppose I will just to hopefully help you see it. So the green one is ABC is the green one. So A to B, to C, and the other one then in purple is my DEF one. So E was on the ground here, so E is also on the ground here. So finally there then, that is the true length TL of the line of intersection. So we want to look along that and get the dihedral angle where both planes will appear as an edge. So just use a set square for this. So that's my angle for the line of intersection there. There's when I look along that true length. And just project a few other points while I'm at it. And just keep that XY line pretty close. Okay, so again we're projecting from this view, so it's from the last XY line back. And the first thing I'm going to get is the point view of the line of intersection, because both ends are the same distance. So that there, I'll put it in red. That is a point view of the line of intersection. So I'll just take a so really and truly now, if I was under pressure for time, I could just draw, seeing as A is my green plane and it's going through that, I could just draw this here and one point on the purple plane, so projecting from here. So I'll just take D. I've projected D. Okay, so I'll just take D. So projecting from here, last XY line back, so that's my distance for D. So if you were in a hurry, you can just use one point and that should be your dihedral angle there. But just to confirm the way right there, I'll just take another point or two just to be sure. So I'll just take F. So there is our plane. So that just confirms there now that that's an edge view of that. So, and I'll just take one extra point on the green plane as well. So I have A, so I'll just take, I have a line for C. So when these all work out in a line, it confirms that you're perfectly right. But if your method is correct, the line of intersection and 1 point on each plane will do. So this here is our dihedral angle. I'll just indicate that with a little arrow here. So that's the dihedral angle between the planes. Now the last thing we were asked to do here is the 10% offset. Okay, so I'm just going to label this A and that's C, and I'm going to find B, I think, actually. Now there's two ways of doing this. So now I could take an auxiliary this way and get the true shape of that, but because if you look carefully, and you should be always looking out for stuff here, AC is horizontal here, parallel to the XY line, so that's a true length in elevation. True length in plan is kind of like this 45-degree set square, and that triangle is kind of hanging down like that. And what I could do here is just leave it swing down vertically and find the true shape of it in the elevation. So I think I will do that. So the true length of AB so I'm going to get the true length of AB using a rotation here, I think. So here's AB. So if I rotated that in, bring it up, height across. So that here to there, that is the true length of AB. So I'm going to take that true length with my compass and swing that down here and just drop B down here. So this here now, I might use a different color again, even though I know I'm using a lot of colors here now. But this is the true shape now of ABC. So if I wanted, and I think what I'm going to do here is I'm going to transfer this out because it's going to be a bit complicated otherwise. So that's 120. And I'll just take the true length of AB, which is that, and the true length of AC, which is this. Okay, now that here is the true shape of A, B, C. So what I want to do here is I want to come 10 millimeters inside. Now I'm a little bit hesitant to use the compass for this, but I will because it's a neat little way of, so I'm just going to step off here a distance of 10. So that's 10 millimeters. So I'm just going to step off my 10 millimeters here with the compass. So, and I'll just show you there a nice easy way of putting I'm going to just use compass arcs and a tangent line to them. So that's 10 millimeters inside here. Just any two random arcs of 10. So that's a useful way of doing parallel lines. So that's 10 below here. And finally, just measure this one. Okay, so really that's what we're looking for over here on the green triangle. Okay, is we're looking to draw this 10 millimeter offset. Now the problem there, I'll just put it in here in yellow. But the problem is, it's easy to do it on a triangle that is a true shape. Okay, now I can use the fact that it is, if I extend this line up here, and I'm going to call that 0.1, and if I extend this up 0.2, and if I measure there exactly, I'm getting 15 mil, but I'll just step them with a compass anyway. So I'm going to be able to use them now on the green triangle here. So that's 0.1 and 0.2 on the green triangle, and because this is symmetrical, if I could find one more point, so if I extend out here this line, so if I call that 0.3, and 0.4 will be symmetrical. Okay, so I know that it's this distance N from B, but what you need to do now is you can use a thing called proportionality. So if I measure that there and I find that obviously it's 10 mil in from the end there on the true length, so if I take that in and step that 10 mil in here on the true length, when that lifts back up, it's going to here. So that's my 0.4, and I can do the same at the other side. I can come in this 10 mil here and just lift that back up. So that would have been 0.3, and I know that 3 goes to 1 up here, and 4 goes to 2. And finally now I just need to get the location of this line here. Now again, there's one nice trick you could use to find that, is if I was to bring that up to here, and I'm going to call that 0.5, just brought that vertically up to 0.5, I can take that distance in here. And it'll be the same from the other side, and just drop that down. And just by coincidence, it ends up being at the height that I took the section plane, just by pure coincidence. And that there is the offset of 10, but there's Nice bit of work there in that little offset part of that there now. So I suppose I should have put that in green actually, because it was on the green triangle, but so yeah, nice bit of work in that question there now. So I hope you enjoy doing that.